My name is Linda Ncwane. I'm the project manager for NCPC. I will be your facilitator for this session for today. We basically got two important presentation. The one will be done by the IFC. I will not necessarily introduce him. I will want him to introduce himself. And then the second one will be done by our colleague Brent Gollat, who was the facilitator in the first session. So he will take us through and do some case studies to see to showcase rather implementation, showcase demonstration to say the IWE project is working. Without wasting any time, I will call upon the stage. I will call Mr. Darrin McComb to just take us through. He will just take us through on the most important topic. We call it water metering and monitoring guideline for agro-processing sector in South Africa. I think it will just take 1 minute. I think one of the most important thing in any facility is to make sure you do have measurements equipment, because that is basically your starting point. Even if you were to do any saving, you can't really do saving by doing just thumbs up to say, thumb sucking to say you don't know. You have to really quantify. So this is one of the most important what you call a first step when you are in a journey in terms of water efficient, even in energy. You must make sure that you measure properly and you measure correct parameters as well. So without any waste of time, let me give the floor to Mr. Darrin McComb. Thank you.
Thank you, Lindani. Before I give a proper introduction of myself, I must just relate the story. I previously got asked by the NCPC to do a talk at one of the energy sessions at the manufacturing in Durban, and I came in early on time, was sitting in the appointed facility, and was told that I was on a panel of 5 people, and I duly went up on the stage, took my seat on the panel, and everyone took their seats as well, and there seemed to be one seat missing, so someone scrambled around and got another seat, and somehow we managed to confuse which room I was meant to be in, and I ended up sitting on a panel that I wasn't meant to be sitting on. And obviously they went, person by person to give their view on the specific topic. And as my wife always says, I always seem to be able to speak confidently about something I know very little about, and certainly that day that is a pointing case. Well, I'm privileged to say that actually I do know the topic. I'm not meant to be here either, so it's ironic that the NCPC haven't asked me to do another talk like that. And even today, I wasn't asked to do this talk. I'm actually standing in for Raymond, Greg from the IFC, and because he came down with COVID, so at last minute we swapped roles. So I'm not necessarily an expert on the topic, but I did write this manual, or most of it. It looks a lot better when I sent it in, and so the NCPC has done quite a lot of good work. The first thing about this metering and monitoring guidelines, as Lindani said, listen, when you've been in doing efficiency work in industry as long as we have, you go into a company and you're saying, listen, where are your metering records? And the amounts of companies that you're going to, large companies, say, using 45 megaliters a month worth of water without a meter. And then you're trying to find a way of optimizing what they're doing, but you're having to guess at how much water they're using. So, and on the back of work that we did for the IFC, specifically looking in the red meat industry, we came across a lot of small little abattoirs, mostly rural, because if you urban, you're getting billed by the municipality, but the rural guys pulling water out of the ground, using it in their processes, and then pushing it out into various areas without a single meter anywhere in their facility. The only meter that they would have in the facility is the electrical energy meter. The rest of it, there was nothing. So in part, this guide is kind of a response to that dynamic, where I think the vast majority of the agro-processing sector in South Africa, be it a winery, be it the guys in the red meat sector, a lot of people do not have adequate metering in place. So we wrote the guide with a couple of people in mind. First of all, sometimes the person who gets delegated the job of putting a metering program in place might be the engineer. So we've written the guide so that the engineer can put it up, and he's interested in costs and where he should meter. And he knows what's in his plant. But he knows nothing. He knows nothing about management systems. It must work, and he's got his contractor, and you'll go in and you'll put the meters in, and you'll collect data, and that data, nothing will happen to the data. And that's not good. So I've been into plants where they've got over 500 metering points billing or metering on a second basis. There is such a thing as too much data. So when you putting metering systems in place, you've got to think about what you're going to be using the data for and how is it going to inform decision making. So the second person we wrote it for is for the environmental manager, or the person who is given that responsibility. Often it's a shared role, and that person knows nothing about equipment, knows nothing about contractors, knows nothing about maintenance. So we wanted to write a manual that appealed firstly to the person who understands management systems. And there's enough information for them to put a budget together and hand it down to a contractor and say, actually, this is where I want metering points. This is the type of metering I want. Please run with it. So there's a lot of good work that's been done. And if you got that manual, you'll see referenced a lot of work. Even Green Cape has done a lot of really, really good work, a lot of background information on metering and fine-tune this type of meter and what it's good for. The WRC spends a lot of money actually developing guidelines on metering, but very, very few of those guides actually give a practical guide in terms of coming from a management system perspective and informing a budget and key metering points within an agro-processing concern. So this is kind of bridging the gap between someone who needs to get the job done and build a budget and know where to go versus the guy who wants to know a lot of information about a specific type of meter. So we've gleaned information from various very, very good guides, which are in the appendices, and it's a useful resource there to go and actually see. Most of them are freely available online. So we have referenced those, and they're available in there to actually to take a look at. Okay, so that's introducing the topic. My role is I'm really just a consultant who spent a lot of time running around a lot of factories. I've probably done maybe 400, 500 assessments, different from small little concerns to brewery-sized plants, cement kilns, those sort of things. So I've been fortunate to be exposed to a lot of different realities within the South African context. And I've brought some of that experience into what we're doing here. So is this presenting? Can I just flip through? There we go. A couple of thank yous, first of all. And I must say, the International Finance Corporation, I've been privileged to work with them on 3 projects now over the last 5 years. I've never worked with a team who've been quite as streamlined as they are around getting something which is relevant on quite a tight budget. And really, they hire very, very good project managers. Raymond, who's meant to be presenting now, one of those, highly qualified and well-trained guy, and their team are actually quite streamlined to actually getting the job done. But at the same time, they're very good at collaborating. So there's a cooperation agreement with the NCPC, and that's why you'll see this manual actually almost as an NCPC document. And there are various funding concerns. So SACO came into it, so the Swiss Secretariat for Economic Affairs, and then also the Ministry of Environment from Denmark. So with all these role players, the Department of Water Affairs was in there as well, or the Water Research Council. So all those role players were in the mix and were collaborated, and we held workshops to actually get a large amount of people's input. So when you do a workshop for people in government, what do you speak about predominantly? Regulations. and at the same workshop, you got the guy who's currently not complying. So it creates a very interesting dynamic in terms of trying to facilitate productive engagement in terms of how to move forward. And then just some thank yous to Victor, Kevin, Lindani, and Julie, who made this document look quite as well. So the NCPC have put quite a lot of effort in. Alpha, I know, was also quite involved. Brent, did you have your fingerprints on this manual? Yeah. Brent too. So I think it went quite widely within the NCPC. I don't think everyone likes the flavor, but actually we have a document, and there might be a version 2 that that improves on it. But a lot of people have collaborated on this project, and just thanks and acknowledgement to them. I'm not seeing what's there. Is it possible to do that? Okay, so I mentioned that the manual has been structured from a management system point of view down. So when we look at the table of contents, when eventually it comes up again, you'll see that there's certain terms that come up, and that whole circular way of looking at things. Thanks very much. So if you've done energy management systems, this framework that you're seeing is a part of that. In fact, we lean quite heavily on the UNIDO ENMS guide in drafting this document. Whether you're measuring energy or whether you're measuring water, really you're using the same approach. And what we're trying to do is saying, listen, what are you measuring and why are you measuring it? Each section in the guide, you'll see sections 1 and 2 are identifying the need. Section 5 is actually developing a metering plan. Then section 6 is dealing with how do I select the meter, and actually what do I do with the data. Section 7 deals with budget, to be able to allow a person to actually put a budget to the program they're trying to do. Then looking at some detail around meter installations. A lot of that we actually make reference to other documents. And then finally, how to analyze and interpret the data. So we're going to move through each section. I'm going to give you some snapshots of the manual and just explain the thinking behind it. So identifying the need, first of all, this is the business case. And if you look at South African cost of resource, not necessarily rural sector, but definitely in the urban sector when it comes to water, but urban and rural, if you're looking at resource costs over and above inflation, you're looking at about 4.5 times the rate of what inflation is. So that trajectory is still going up. I won't say it's a log curve, but it's still an increasing cost. So as a percentage of your cost base, South Africa, who typically would have had cheap electricity, now as a percentage, actually it's increasing. Water is becoming something that organizations are having to look at, because actually it's now as a percentage a bigger piece of the pie. There's if Kevin Cilliers was here, he would say quite emphatically, installing meters does not save money. Now, I agree, but I also don't agree. Installing VSDs also doesn't save money. Installing timers doesn't save money. You've got to set the thing. You've got to use it properly. But installing meters gives you information, and if that information is used properly without doing anything else, you can save money. And a point in case is, and you'll see these case studies coming through in the manual, RFG Foods, and this is a client of the NCPC's. We did some assessments there, and what you're seeing there is their live electrical logging, and that little red line towards the right with the red block around it, that's where the power factor stopped working effectively. And really it's just the switch tripped off. So yeah, he's got this live logging, and when I asked him for the data and I was looking at it, and I saw, okay, but listen, your power factor's tripped. The guy says, no, that can't be right. And then we walked down and he flipped it up again. That was costing him 20,000 Rand a month. Sure, it had only been down for a month and a half, so it was a 30,000 Rand cost. It's likely at some point someone would have realized, so how much are you saving? It's hard to quantify, but it's important that when that power factor tripped with the metering systems he had in, he should have got an alert. He should have got an email saying, listen, the power factor's dropped below 0.95. Please, look at the power factor. So there's a good indication of how just having proper metering in place would have actually saved that company money. Same company, different site. You can get information from your municipalities in terms of half-hour billing data, and it's very easy to take that information and to plug it into the different tariffs that are available. And this client was on a peak demand tariff, and they went to a time of use tariff, and they saved money straight away. Without that data, you cannot make a decision. With the data, you can make a decision, and the savings are there to be seen. Now, developing a metering plan, and as we say, so you need to set your objectives, and if that objective is, listen, we want to have, like the Levi project that was mentioned, we don't want to draw any fresh water. They want to have a zero water footprint is effectively the target they set for themselves. So there are two things there. You can minimize, but you're not going to minimize to zero ever. You can look for alternative water sources. Groundwater being one, the council reclaimed water being the other, rainwater being the third. There are other water harvesting options. You can actually use a refrigerator to generate, but the amount of water they're using, that wasn't viable. But it depends on what you're trying to do. That informs your metering program. There's no point in actually having an objective and have no way of actually measuring whether you got there or not. So just some examples. If you do go into metering, you don't have to necessarily install live logging. There are different types of meterings. One-time spot measurements are entirely appropriate. So going in there with a clamp-on ammeter will tell you exactly what that pump is drawing. No need to log that continuously because it's running continuously. Runtime measurements, so you're putting it in for a period of time, or alternatively is giving you on-off. It's giving you the hours that the thing's running. So typically compressed air systems, you'll see that little compressor will give you an hour counter, and that's a good indication of that. Short-term measurements, and we do this often in fan and pump systems, is we'll go put kits in for about 2 to 3 weeks. And that gives you a reasonable idea. It's an expensive task, but it's cheaper than actually putting the equipment in full time. And the last is the long-term monitoring. So there are 4 measuring philosophies, and they're all applicable. So this table just tells you when you'd use what. Then what we've done, and bear in mind, this is agro-processing concern. Typically, you've got a boiler. Typically, you'll have a chiller system, and you've got departmental water usage or energy usage. So we're saying for a typical agro-processing concern, an ideal monitoring system on the electrical side is you're looking at the main incomer, both consumption and power, quality. So quality is important. And then each individual department you want to look at. So if you're looking at how much the product's using, that's going to be metered. The compressed air plant, amount of plants we go into, compressed air systems using $1 million plus a year in rand value. 15,000 rand meter will normally save you that money in a very short space of time. So there'd be a meter there, but sub-metered as well. So plant as a whole, and then the 2 compressors. When I've got a line in, you can get away with just putting 2 meters on the 2 compressors, and you just sum the 2. So you get something called a virtual meter. You can sum the 2 of them without putting a physical meter in. And then finally, on the chiller plant itself, it's important to actually be metering that as well. Water schematic, and just to go through quickly, you typically measure your departments, your boiler house, your chiller plant, your cleaning processes, your alternative supplies into the plant. So borehole, rainwater, doesn't matter, that needs to be metered. The quality needs to be metered. And now there's a difference between metering live and doing your sampling. So water quality going in, you're probably going to take monthly grab samples to actually check the quality on your alternative water supplies. But I've put down there the Q for quality. And under quality, we do speak about in the manual what you would typically monitor on incoming water as well as outgoing. Now listen, you can write a very thick thesis on effluent treatment technologies and effluent parameters and that sort of thing, but we're really streamlining on the important things. So when we speak in the manual, we're speaking about COD. So organic loading would typically be something you're looking at, pH, TDS, and the reasons we look for those, because those are the things that council builds them on. and this manual has been written in such a way that actually it's streamlined to ensure that the companies save money. Boiler system, and there are a lot of systems, so where would you measure on a typical boiler system? If you've got money, so we go into quite a lot of depth. There's a way of measuring the steam rate without actually putting a steam meter in. So there's a nice little section there, and for 15,000 rand, you can actually calculate your steam rate fairly accurately, and probably more accurately than what a steam meter would do on a boiler plant. So we go into that. Then finally, on a plant level, there's what I'll call a basic measurement plan. And if you've got good enough eyes to see that small print over there, a basic measurement plan should save you about 2% on your electrical and water bills on an annual basis. Roughly, assuming you're using the information intelligently. And what would you be measuring? So what we've done here is we've just given this table, and this is where the management system approach, someone who comes from a management system background would look at this table and think, great, you know, the maintenance engineer is going to look at this and be confused, you know, but it's kind of giving you, okay, well, if I've got a limited budget, what should I be prioritizing in the measurements in my plant? And that's what I call the basic measurement plan. There is what I would call a normal measurement plan, which is a different table, and then there's the advanced measurement plan, which is in this table, and that's now you're going down to the level of measuring individual chiller COP. You'd be measuring that. That means you're measuring power and you're measuring temperature and you're calculating flow. So now we're going into the advanced measurement techniques for actually being able to look at it. So on a boiler system, you know, you would be measuring certain things. You'd be measuring the O2, and that would be modulating your fans coming in. So that's what I call advanced measurement techniques. And there we would expect 10% on resource consumption and on, well, your resource costs. Where does that 10% come from? It comes from years of experience. So I put my name there, and I like going into plants and arguing with engineers, because often you're going in there with a lack of data. So I normally, when there's no data, I put an estimate in, an educated estimate, a calculated estimate, and I'm open to the guy giving me a better estimate, because if there's no meter, you know, you can't make decisions in a vacuum. So it's always good to put your assumptions down and let them be debated rather than actually having nothing. Because most of the plants, they don't make decisions, and the reason they don't make decisions is because they don't know, and no one's prepared to actually provide an estimate. So I find more often than not, I go into plants and I can impact on plants, not because I'm smarter than the guy or because I know more than that maintenance engineer about his system. It's because I've got tools to help me to estimate how much his specific systems are using. And those tools have been tested, so I know they work. The UNIDO tools that are available are brilliant. They're really, really good. I've been on most of the UNIDO courses that are offered by the NCPC, and I can highly recommend them. Okay, selecting the meter and data storage. So we go briefly into, and whether it's steam meters, electrical meters, or water meters, and this is taken straight from another manual that was much better than mine, and I'll make reference to that manual. But yeah, it's just kind of saying, listen, in different settings, you're going to use different types of meters. And if you know nothing about meters, at least the table is going to help inform you about what the right meter is to choose. So from metering, collecting the data, to storage, and again, this is the management system coming in. How are you going to be using the data? There's no point in having a guy going around and collecting 50 different meter readings, putting it into his book, which happens. I often have to go into books, take snapshots, and then load that stuff into spreadsheets because this guy's collecting all of that. Or even putting it into a spreadsheet, and everyone knows where it is in the spreadsheet, but it's not coming out. It's not triggering any response. It's not informing someone. So that last loop must work. And nowadays, you know, with technology that's available, especially online systems, if you can plug data in, you can get something to spit something out and tell you more or less what's going on. So there are different ways of doing that, and we just touch on that very briefly. Determining the budget, and I think this is the unique part about all the manuals that I've seen, is we've actually gone to the market and we've got some indications on costings. It's debatable. Obviously, it's assuming there are no complications with where you're installing. So no installation complexities. This is more or less, and this is back in, well, 2021. So whenever that's dated, it'll give you a rough indication of the size line, what you would expect to pay for a standard meter going into that. And then in addition to that, you want to know, what is it going to cost for me to effectively meter a compressed air system? And we've done that as well within that manual. Compressed air systems are pretty pricey things to monitor. Those flow meters are pricey, and the data log is a price as well. So compressed air systems are often measuring on a sub-second basis, not on a 15-minute or 30-minute basis. So you've got a higher spec piece of equipment that goes in there. And what we've done is each system within a plant, we're saying, okay, well, if you had an ideal monitoring system, what would that cost you per point? So per chiller that you're going to be monitoring, more or less, what are the costs? What are the sensors that are going to go in there, and what are the costs of those sensors? I've utilized people who supply that equipment, so it's coming from actual quotes. And what we are finding, data storage, communicating and transferring that data to an online platform is increasingly getting more and more cost effective. So you'll see their monthly subscription point, that 60 Rand per point measured, that figure keeps coming down. That point, 5 years ago was probably about 200 Rand per point per month to measure. It's now 60 Rand. So the costs in some parts of these are coming down. Smart metering costs are coming down with the technology. Smart homes, there's interesting stuff happening, and some of the costs of metering is going down, but some of the costs are obviously going up. Water meters typically metal, and metal prices will be increasing, and normally parity priced against what international steel prices are. So for a standard plant with certain systems in place, if you want to have a comprehensive metering program in place, we've done that budget for you, and it's roughly 850,000 and 2,500 Rand a month worth of subscription costs if you're going to put that onto one of your online service providers, give or take. I might be wrong by about 10%, but the point is to at least have something to start with. That's the point, actually. And yeah, you can see there that compressed air system, 180,000 Rand to monitor. Now, if you've got a little 5 kilowatt compressor, you're just going to scrap that one out. It's easy for you to take things out of what we've done here. And juggle it like a puzzle to make sure that you can actually fit it for your purpose. Here's just another case study. So I've got these intermittently put in. What we've found is companies who've put metering programs in place. And I went into ABI 2011. I did a resource assessment there. And back then they were using about 5.5 liters. It's hectoliters per hectoliters, but their ratio is 5.5. When I went back there in 2018, they dropped that down to 2.5. I think it was 2.3, 2.5, somewhere around there. When I went back there in 2020 to do the case study, they were targeting 1.7. And that their whole philosophy is they're metering just about every single water point in that plant and using the data intelligently. So it's a really good case study for a plant that's been able to consistently apply a measurement philosophy in its processes and go through there. I've got the picture of those two tanks there. One of the things they realized, they had this they're reclaiming water from one of their processes. I think it's the incoming water, the backwash they were reclaiming. And they thought, there's plenty of water available there for wash down in their pre-crate wash area. So in other words, it's the low care areas. And but that actually wasn't the case. That one tank is a reclaim tank that feeds an area in the plant. But if that tank gets too low, it gets made up by municipal supply. And they didn't know how much was being compensated by municipal supply. And when they started metering that, they realized actually there was a problem with the valve, and a lot of that stuff was overflowing. And they changed their control valves, they put a meter in, and as a result, they actually were able to save quite a lot of money. But it was they didn't know, they had no idea until they put that meter in place. And that meter is in between those two tanks. So data analysis, and I must say I love data analysis, and the NCPC's got an excellent course, the ENPMI course. So what you're seeing here is a ratio graph. This is a Tyre factory, and it's over 3 years, and you can see on a ratio, so they're looking at a kilowatt hour use per kilogram of product or production. And you can see those spikes coming up there. So the spikes going up to 5 per kilogram. And those spikes are typically in December, January months. So it's the low volume months. So this poor guy, he's on a KPI. And every December he comes in and he knows. And no one takes the data seriously because they know, listen, low production. And we see our KPIs. The vast majority of the stock market are still measured in this way. And a lot of companies still use this. And it has this place, but it's obviously got problems. So the way we'd recommend is using a statistical tool. I'm not going to go into the detail on a statistical tool, other to say that you're using Excel spreadsheets and you're using some of the regression tools in Excel to help you generate a formula, a predictive formula that's telling you, given another variable. So if the variable is production, how does that influence my resource usage? So yeah, we can see production has quite a strong influence. So in that plant, we actually developed a model to say, okay, well, given the different levels of production, what are we expecting to use? So that's what regression analysis allows you to do. Now, this little graph over here, you might not see it. The guys online will probably see it, but you guys can't quite see it because of the colors. But what you can see, the simple ratio over here. So that simple ratio, and when you look at that, you're seeing one is an error over there, April 2020, that was COVID, so they were shut down. But April 2020, you can see those winter months from April through to August, their performance drops significantly. So that's what that graph's showing you. But then we notice, actually, listen, production has a role to play in terms of how much energy they use. So we developed a little statistical model, and that's where, and this is coal consumption. So the statistical model spits out what the expected consumption is. This graph, this side's showing you what their performance is against what we expected. There's green, you're struggling to see it, but there are a couple of points that come in here that previously, you'll see here, for instance, in April 2020, we're not using intensity anymore. So we can actually predict during the COVID month how much coal they should have used. And where's that coal going? It's to keep keeping their system warm. That's what radiation losses are costing them. So statistical models will help you to predict your baseline, your base load. Then finally, what we did is we said, okay, well, listen, clearly winter's got an impact. So we developed a model which took production into account and took winter into account, and some interesting things happened. Again, we were able to predict in April 2020 what their consumption should have been given weather data. But this data point over here, which is June, which for both the intensity target and for the production target indicates that they were actually inefficient. When I plug it in there, it actually shows no. For that month, they actually did quite well because temperature has an impact in how much energy they're losing in their system. Now, if you can think of a rubber plant or a tire plant, there are two things in it. A, radiation losses in the system, but the compound itself. They've got to heat the compound. The raw material's coming in cooler. So it makes sense. You would always need to take temperature into account in this process. So this is what we developed and the model developed. So and that's how we use the regression analysis. So this is just a case study looking at a compressed air system. It's a bottling plant. When I say bottling, it's a PT or a dairy bottling plant. And they had two compressors. So it's a blow molding plant, a 215 kilowatt compressor and 185. What we did there is we put the monitoring systems in place. We ran one for 10, 15 minutes. We ran the other for the same period of time, same demand. And you can see this little red line there versus the red line on the other side. The energy consumption on the 250 kilowatt compressor for the same load, same pressure, was about 25 kilowatt more, 10%. And that's because the compressor is less efficient. It's operating at lower load. So information like that helps you with your decision making. And what we find often is that maintenance engineers like rotating their compressor usage, and they'll run the one for 1 week, run the other one for another week, and clearly in this situation it would have been better to actually run the more efficient one for a longer period of time. So the last case study is using the tools that we spoke about in the metering guide. You're able to actually determine your overall boiler thermal efficiency, and that's what we've done over here. we worked out what their generation efficiency was, looking at flue gas analysis, but also looking at fuel in versus steam out. We were able to calculate what the line losses were, and the overall system efficiency here came in at about 33%. So for every 100 kilograms of coal you're putting in, you're only getting 33 kilograms of useful energy out. So clearly there's a problem there. This plant, they decommissioned the steam boiler, they put in a hot water system, and as a result, they were able to actually improve the overall system efficiency to about 80%, and there were significant savings as a result. Okay, so I think that covers our, that covers the end of this section. I'm happy to answer any questions, but I think we've probably got Brent coming up now to take on the next session.